Well, to start off today, I want to tell you all a story. Orbiting silently 250 miles above Earth's surface, there is a place, a real, tangible, and quietly extraordinary place where humanity is not divided by borders, but it's united by purpose. Up there are no nations, there are no lines drawn in the sand, there's no echo chambers of ideology. It's just 11 human beings floating, collaborating, searching. They represent the United States, they represent Russia, Japan, India, Poland, and Hungary right now. Some countries that down here on Earth are tangled in disagreement or conflict. But up there, in this microgravity, their differences dissolve. Together they grow crops. They imagine a future where food can be cultivated far from Earth. They study microscopic algae. They explore new frontiers in nutrition, oxygen generation, and clean energy. They examine how our bones and muscles might regenerate, how organisms like tardigrades, which is life in space, survive the impossible, how atomic particles behave when they cease to be individuals and become one. Every experiment, measurement, every day on board the International Space Station is a testament to what we can do, not as Americans, not as Russians or any flag-bearing identity, but as human beings. And this isn't a dream. This isn't science fiction. This is happening right now. The International Space Station is living. It's a breathing symbol of global collaboration, of possibility, what it looks like when we set aside ego and elevate relationship over extraction. When we stop asking who gets the credit and start asking what can we create together. So that's what we're talking about today. We're going to dive into the ISS, not just as the technological marvel that it is, but as a philosophical one, as proof that like unity is not a dream. It's possible. It's already happening. And if we as a species decide to take this model, this orbiting microcosm of cooperation, and expand it, what else could we build? And what kind of future we might create? Let's talk about it, Randall.
What kind of future could we build? Yeah, pretty much anything we could imagine.
And we're
Almost
seeing
anything
it.
we could imagine. That's right. All of the visions and dreams and images and symbols that you grew up with, what I grew up with since I was a kid in the middle of the 20th century, have sort of pointed us in the same direction, up and out, to expand. And I think we're seeing that. Is it going to be challenging? Hell, yes, it's going to be challenging. Is it impossible? No, I don't think it's impossible. Does it need to happen? I think that it most likely does, that it really needs to happen. I have thought about this for years and years, decades. I can't see another way out for the human species, for human civilization, unless it expands. And I think, personally, I think that's our destiny. I think if we are moving along a trajectory determined by a DNA blueprint, a DNA mandate, I think that's where it's pointing us to. I think it's pointing us to the high frontier, to the cosmic frontier. And can we do it? Yeah. I mean, I think we have precedents throughout history of humans coming together and doing impossible things. As recently as 700 to 800 years ago, building Gothic cathedrals all over Europe that were literally, I mean, launching, when you go back to the beginning, those first few decades of the 1100s, when that movement was launched, I mean, you had an entire society of people that was willing to put their shoulders to a work that would not be completed for at least 2 or 3 generations beyond their lifetime. Yet something motivated them, something inspired them, and they did it. So you would have 3 generations of a family working on a single stained glass window. Go to France, go to Chartres Cathedral, stand inside when the sun is in the west and look at the great rose window. And then imagine what we could do. I mean, yeah, we can definitely create new worlds with what we now have at our disposal. The tools we now have, the physical tools, the industrial tools, the scientific tools, the intellectual tools that we have, we can begin to create miracles. No
These
question.
spaces are Gothic cathedral of this age.
That's how I see it.
You've said that before on our podcast, and I think it's a great example of if we are to look at something recently, and we could look a lot farther back, but something recently that brings people together to create something that is not only inspirational, but as we're learning, is a reminder of our humanity. And in our case, we have the ability to, expand us into a different type of species, a different type of civilization. Okay, so we talked about lots of things that have been speculated about over the years, but there's a really good example of something incredible that happened back in April. And in April, there was 6 rockets that launched into outer orbit in less than 24 hours. I think this is a really good place for us to start around coordination. Now imagine if those 6 rockets were launched out into space with a common objective or a common purpose for us to expand, for us to do more research together. What do you think would be possible if that feat was not just about the privatization of something or the extraction or who's going to win the contracts for humanity? Contracts for who's going to get the most money to keep their research going, but was about humanity as a whole and expanding our civilization.
Well, I'm very excited to see this reinvigoration of the space program. And I see 2 ultimate causes of that. One, other nations are picking up the ball. You see India with a space program. You see Japan with a developing space program. In fact, there are now 70 countries that have space programs, right? 70. That's pretty impressive number. So we're getting some impetus from outside, right? The other, I think, is the private space sector. I mean, where would we be without Elon Musk's contribution, whether like him or not? Without his contribution, the American rockets that went up, of those 6, were Falcon X rockets. So, and there's also Mr. Amazon.
Jeff Bezos.
Now,
the Atlas V.
I used to not particularly like Jeff Bezos, but he has gone politically. I've seen him shift to the libertarian perspective, and I hope he keeps moving in that direction. What he did was at the Washington Post that he bought. And he's made a declaration a few months ago that he was going to open that up. It was not going to be censored, and he was going to give a lot of points of view, including becoming an advocacy of freedom. So I'm okay. If you really do that, if you're sincere, I'll get behind you with that, man. Now you put that with what he's doing with the space program, with his space and his launch. Aside from the fact of the ladies going up a few months ago and what happened, I don't know what that was all about.
Hey,
did they really go up? I don't know. I hope they did. I want them to have actually done it. I don't want it to be a hoax. But, I mean, if they really did, then there was a time when such a thing would be inconceivable, right? Even now, when you look at the astronauts, all of them, including the women, are as highly trained as the men who are up there on the space station.
Yeah.
And what it is, I think there's three women up there.
I believe so. There's 2 that are there permanently from the United States, Anne McClain and Nicole Ayers.
I think it's Ayers, yeah.
Ayers, excuse me, not permanently, but in the 6-month rotation that they do. And then Peggy Whitson, who is a part of the 4 astronauts that just went up at the end of June to do, I believe it was research on algae. That was one of the main things that they're focusing on. So there's 3 women from the United States there. And then there's 3 Russian astronauts as well. There's a Japanese astronaut, and there's an Indian astronaut, a Polish astronaut, and a Hungarian astronaut.
So these are the 4 that just went up. Let's see who we got here. Let me shrink this down a little bit. There we go. So we've got Axiom Space's X-4 crew. From left to right, mission specialist Tibor Kapu. Let's see, where is he from? He might be the Hungarian.
I believe he is, yes.
Pilot Shubhansa Shukla. Well, he's got to be the Indian.
He is.
Commander Peggy Whitson. And
USA.
who, by the way, holds the all-time USA record for extended time in space.
Oh, really?
Yes. Wait a minute. Let's see. Mission specialist Sławomir Uznansky. Maybe he's the Hungarian. Let me see.
Uznansky. No, he's Polish.
He's the Polish, of course. Yeah, there we go. There we go. Let's see what else we got here. There's Peggy, International Space Station crew member and holder of the record for the most days spent in space by an American.
Wow. It's amazing. And this is the list of things that they're working on, some of the projects that they're working on there.
Okay.
The top one is space agriculture. How are they going to grow fenugreek and mung in space? So a focus on sustainable food construction off Earth, production, microalgae cultivation, which is focused on edible microalgae for food, oxygen, and fuel generation. And then they're doing bone and radiation studies for how can humans survive long-term in space, as well as, and this is my favorite, tardigrade research, life in space. You know Chandra Wickramasinghe's work, right?
Yes.
Yeah. So people always say, oh, we found the building blocks in space, right? Well, he was very adamant on a podcast that he and I did that this is life. This isn't just the building blocks of life in space, but they're studying their extreme resilience because they found tardigrades on the outside of the International Space Station, which seemed to be in some type of hibernetic state that allowed them to survive out in open space. And they're continuing that research as well.
Do you have a picture of a tardigrade so people can see what you're talking about?
Yes.
I can kind of picture one. I don't think I'd.
They look like little space bears, little space bears and water buffalo. A lot of these are AI depictions of this.
So what happens if they escape from their confines and they take over, and then they come down to Earth and they start breeding by the billions, and they're 8 feet tall? Then what do we do?
I don't know, Randall. Maybe we try to make friends with them, right?
Okay.
We don't domesticate them would be my advice.
Well, we explain the principles of international cooperation to them, and
yeah, I'm sure they're well versed in human dialect.
Okay.
But it's very interesting because I love that. I think it's important for people to talk about the International Space Station, which is a global project, is researching life in space, a different life in space. It's amazing.
It is amazing.
A few of the other things as well is they're testing muscle generation, myogenesis. So muscle cell supplements to combat atrophy in space. I didn't get a chance to research that very much, but I thought that was very interesting because, we're talking about all of these topics kind of lead me to jump to the point of, okay, well, if we were not serious about creating civilizations out in space and colonies out in space, then why would we be looking at how do we eat? How do we survive? And then how do we thrive? How do we make sure that we can continue to live long lives that are healthy through muscle density and bone density and our ability to continue to essentially be healthy in space? Because they're also looking at cerebral blood flow as well as just consistent health screening, which I know has been a very, very big part of the research for a long time, but it continues, and there's 4 people who have joined the 7 with a specialty in or with a focus, excuse me, in those categories. Plus, I'm sure a lot of other things that is not public knowledge.
Correct. Yeah. Yes. Well, let's see. China has had some successes recently. Let's see what, and of course, if that turns out to be an impetus for us to get our asses in gear, yeah, absolutely.
Yeah. I know that there's the thing that was in the news the most about China was the research that they're doing on the dark side of the moon, going to the other side of the moon, and or at least publicly saying they're going to the other side of the moon and sending drones, I guess you could say, or rovers to do some more exploration. I know that was very, very popular or got very, very popular because a lot of the media outlets in the United States kind of picked that up. And I mean, we're saying, hey, if they're doing this, we probably need to be thinking about doing it as well.
Well, there was a story that came out in late 2022 about their latest, the Changasite Y mission that they sent up to the moon. And this was a report that appeared in The Independent entitled, China Plans More Moon Missions After Discovering Potential New Lunar Energy Source. Changasite Y makes prospect of mining the Earth's satellite in the future increasingly likely. China is planning 3 new missions to the moon after discovering a mineral in lunar samples that could be used as an energy source. Beijing's National Space Administration announced over the weekend that 3 uncrewed orbiters will be launched over the next decade as part of an acceleration of its space program. The Chinese Space Agency made the announcement just 1 day after state media announced the discovery of Changasite Y. They're calling it a phosphate mineral containing helium-3. That could prove to be a valuable lunar resource. It is the 6th new mineral to be found by humans on the moon and makes China the 3rd country behind the U.S. and Russia to make such a discovery. The sample in which Changasite Y was found, so Changasite is the name of the site that they set down and grabbed samples from.
Right.
It's China's Chang'e-5 mission, which retrieved rock and dust from the moon's surface.
Interesting. It says contains significant amounts of helium-3, which is a potential fuel source for nuclear fusion reactors. Very, very interesting. Helium-3 is an isotope that's rare on Earth, but abundant in lunar regolith. You've talked about this.
Yes, we did. Yes, we did. And the extraction of helium makes it all the more desirable target. And then here is, let's see, which one is this now? This is the Tianwen first launched last July 23rd. So let's see here. There's the schematic, which is rather interesting how they've done this. See, there are deployed solar panels to power the thing while it's in orbit. Star tracker, attitude control thrusters, fuel. There's the fuel tanks down there, and the main engine. So I don't know what they're using as a booster, but the long range plan is that this thing's going to go to Mars and rendezvous with Mars.
And when was that launched? When did you say that was launched?
I think it was July 23rd of last year.
Right. So coming up on a year.
But yeah, here it is. Here's the blue comes. This in itself is interesting. This is your transfer orbit. You follow that around, and what happens? It changes into this blue right here. You notice this? Here, right at this point, is your Mars orbit insertion maneuver. So you're coming in on your transfer orbit, and then you go to your insertion maneuver right here, and then you've got comes
Randall, pull
around,
that
comes
mic
around,
closer to your mouth.
and you've got your capture orbit, 400 by 180,000 kilometers inclination, 10% period, 10 days. Then orbital inclination change maneuver keeps coming around, and then what happens? Can we make it out here? The blue becomes the green. Here you've got more orbital change maneuvers. The green comes around, and then what does it do? It turns into what?
I guess it follows the same path around, and then at the bottom there where it says number 7 breaks into the red.
Yes, that's what it must do. Shift into the red, the scientific orbit. And then you've got this magenta, which is the final scientific orbit. Okay, so the green is the reconnaissance orbit. Well,
doing recon, make sure that there's no Martians waiting for him down there.
That's right. So, yeah, I mean, China's serious about space.
Oh, yeah.
And if we're not careful, they'll overtake us within the next couple of years. But again, we need to take a leadership role here, and we need to form a consortium with China and with Russia and with whomever else.
With the 70 other space programs.
With the 70 other space programs. That's exactly right.
On United Earth.
Yeah, but wouldn't you rather go to war with all these countries over diminishing finite terrestrial resources?
It seems like a fun Friday night, but I'd prefer a long-term coordination, to be honest with you. You know, when you go to a family dinner, it's like, you go to Thanksgiving dinner with any of your family, Randall?
Oh, used to, yeah.
Yeah, so there's a very common story about when you go and you bring the whole family together for Thanksgiving dinner. There's this, it's not with every family, but a lot of families, there's this sense of dread because, you know, you all love each other to some extent, but you know, when you come together, there's going to be conflict. Mm-hmm. Sometimes you save it up and it builds up. Well, when you leave, you separate from that conflict, right? Well, we have this idea that constantly we need to make every interaction like the dreaded Thanksgiving dinner. We have to continuously fight over things that are really finite. So hopefully we get out of that.
Well, it's, you know, kind of, well, it's up to all of us, but it's especially up to your generation.
Yeah.
What can I say? I hate to say your generation because then that sort of automatically creates this other category because I don't really look at it that way. We're all in this together. But ultimately, you know, I recognize that, you know, I'm not going to be around as long as you. I'd like to be around for another 50 years. And if there's any new breakthroughs, I'll be first in line to say, man, I'm having a good time. I'm doing this job here, and I'd like to at least try to get it finished while I'm still here, you know?
Oh, yeah.
So I would definitely take advantage of that. But here's going back to, now this is Russia, cosmonaut Anton
Shaplev,
I think.
Shaplerov. Anton Shaplerov.
This is back in 2012. So, I mean, they're up there doing this. Well, should we go over to this?
Yeah.
Factors in space colonization, cosmic expansion. Well, number one, I would put this right at the top of the list. Earth is highly vulnerable to cosmic catastrophe. And relatively common cosmic events inflict substantially more damage to the planetary environment than the activities of man, except for perhaps nuclear war. But as I'm saying, relatively common cosmic events can inflict substantially more damage to the planetary environment than the activities of man. A relatively minor cosmic/planetary event would terminate civilization. substantially reduce the global population and impose a new Stone Age on the survivors. It would provoke major environmental destruction with severe widespread habitat loss and an extinction of species. And that's not far out of the question that something like that could happen, because we now pretty much know it did happen, between 12 and 13,000 years ago. Did something like that happen 12 or 13,000 years before that? Well, we don't have any proof of it, but we do have some very suggestive evidence that civilization-destroying events happen way more frequently than we had previously imagined, even a few decades ago. But here's the thing. Mankind has the technical and scientific ability to dramatically reduce the probabilities of cosmic catastrophes affecting Earth and her environment. Now, I say not to completely eliminate the threat. No, we don't have that. But we do have the ability to dramatically reduce the probabilities, and that's the key point. If we can, if we're building in Tornado Alley, we want to do whatever we can to reduce the probabilities of our home being swept away and destroyed by a tornado, right? So there are things that we do. We use hurricane ties to attach the rafters to the top plates. We bolt things together. We have a nice heavy footing and we bolt the framing to the footing. All kinds of things that we can do that are designed to reduce. Now, that doesn't mean that a direct hit of a tornado won't still destroy your house. But winds generated by a tornado passing a mile away are not going to destroy your house. And next point, very important point. Material and energy resources of space are infinite.
Enough said.
Enough said.
Yeah, it's simple. I think that there's an interesting, you talked about Elon Musk earlier. I saw an interesting verbal diagram where somebody was piecing together the different technologies that Elon Musk has been working on. And essentially there's the rockets to go to Mars, but then there is solar development and ability to store it. So you can have mass amount of solar farms on the moon or on Mars and collect unlimited energy, I guess you could say.
In free orbital space. Yeah.
Right. Yeah. And then you also have the tunneling company, the boring company, has all these tunnels, drilling tools that, we might not be able to inhabit we might not be able to live on the surface of the moon or the surface of Mars, but we could live inside of it if we're able to create some type of structure to do that. Well, there might already be one there.
Yeah, I think we've learned as I've been putting out information on the moon, one of the things that I've really emphasized was the discovery of the gigantic lava tubes, which have access to the surface of the moon. It's almost as if the structure of the moon has made ready access for us, very convenient, to the inside of the moon. So that's one of the things that I'm really super interested in learning more about with return missions to the moon is some of these, they've been referred to almost as skylights. Okay, well, think of a skylight. Skylight is in a roof, and then there's a room below that skylight, right? What happens if we go into that? What are we going to find in there? That, to me, is really an interesting question. The next point, colonization, exploration, and economic development of space proceeds in tandem with the development of technologies and systems of planetary catastrophe mitigation, i.e., planetary defense. So as a byproduct of the colonization of space, it will become orders of magnitude easier for us to implement a system of planetary defense.
And we've successfully developed a proof of concept for redirection of near-Earth objects as well from the surface and going to the moon, or even from a space station that has some more technological abilities for production and manufacturing. We'd be able to give ourselves a much better chance than we have now to protect ourselves from something smashing into Earth and setting us back 12,000 years.
Mm-hmm. And finally, mankind is the instrument by which life becomes cosmic. And that gets us back again to the, if you want to call it the genetic mandate, or if you're more spiritually inclined, you might think of it as the divine mandate. I'm cool with either one.
They both sound good. They both lead us to the same conclusion.
Yeah.
We got to make it happen. I think it's a good thing to circle back to on the coordination piece to make this happen, because obviously we've seen a lot happen on Earth over the last, let's just say 11 years, 10 years, in conflict between Russia and Ukraine, and the United States is involved in this as well. And that conflict, let's say it's been going on for 10 years, 11 years. I think 2014 was when there was the first crisis, the invasion of Crimea or something like that. Well, do you know how long we've been working together with Russia in collaboration on the International Space Station when this started?
I don't know the exact year, but I'm sure it goes into decades.
Yeah, it started, the creation started in 1993 of the International Space Station. We've been cohabitating on ISS since late 2000. We've been living together and coordinating for 25 years, which, I mean, that's a bright light right there. It shows that we're already willing to put our differences aside, put these things aside to focus on the betterment of humanity and to answering questions like the ones that you've been proposing for a very long time. So what do you think is the difference between the extended, I guess you could say the extended resources to this question of how are we going to work together to make this happen? Do you think that we're just not asking the right questions? Do you think that when they're being asked, they're being poo-pooed? What's your position on what steps should we take next?
Well, we need to establish an international dialogue, and it has to bypass the tentacles of control of the major governments. I want to see more scientific collaboration. I want to see cultural exchange. I want to see, visiting scholars from many countries coming to us. We visit many countries to learn from each other, very much like we did back in the Middle Ages when the guilds would have exchange of apprentices in order to share the knowledge, pass on the knowledge. That's what I would like to see. Plus, I would also like to see, I think in a sense it'll probably become inevitable once the political structures or the political obstacles are out of the way, because that's really what it is right now, political obstacles. I mean, I think the scientific community of Russia, the scientific community of China, the scientific community of America, we're all ready to start cooperating and working together. But it's outmoded, outdated, corrupted political institutions. That's the biggest obstacle. So strategies of being able to bypass those institutions, I think, are imperative. And do we work within? Well, I think the only way that you're successful is by working within and without. Can it be transformed from the inside? Well, I don't know. Can it? I don't know. I tell you, I was cautiously optimistic that maybe with the new president coming in, that we would see some major changes, but it looks like business as usual times 10. And so I'm disappointed in that. But is there hope of salvation? Maybe. Maybe there is. I assume there's things going on behind the scenes that the rest of us don't know about. But again, that's why I very much am an advocate for the private sector developing and moving forward. I cite the example of some of the great engineering projects in American history, like the building of Grand Coulee Dam and Hoover Dam, right? So these projects were so monumental that a single entity, a single industrial entity, was not capable of taking it on as a sole project. However, in the case of Grand Coulee Dam, it was the three of the top engineering firms, civil engineering firms in the country that had been competitors, and they came together cooperatively, and they built this amazing structure, a monument to the, engineering capabilities of America in the 1930s, right? Then with Hoover Dam, it was, I believe, 7 different companies that came together and pooled their resources that were able to pull that project off. Right now, both of these projects are going on roughly at the same time, overlapping, right? Plus a lot of other stuff going on. So if there's no reason why we couldn't marshal the industrial capability to lead, that's what I would like to think, that we would lead that. Again, I see 2 things. I see people who are just kind of overcome by cynicism, and the first thing, they're dismissive of it. They're dismissive of the whole idea. But they offer nothing. They offer nothing as an alternative. That's the problem. Okay, well, if we don't go this route, what's the alternative? And I've been asking that question since the 1970s and have never gotten an answer. Not an answer that makes any sense. Outside of draconian control of all human activities, which would come through the control of energy, which means production, distribution, and consumption. Mm-hmm. And if you look at the scenarios for net zero, it absolutely cannot happen without draconian energy restrictions in place. And so is there a way beyond that? Well, no. Again, I guess what I'm getting at here is that it all requires major control. What's the word I'm looking for?
Suppression, maybe?
Suppression, that's a good one. Yeah, suppression of human freedom. And rationing. Rationing would be a huge part of it. And in order to have a rationing that covers all aspects of energy production, distribution, and consumption, that means control of all human activities and constriction of human activities, which we already see. Okay, we've got to restrict flying. We've got to, there's factions that want to restrict automobile use. Well, as you and I both know, there are technologies in the wing that completely are going to render irrelevant the whole question about fossil fuel consumption leading to global warming, because there are technologies now that can transmute the pollutants that are the byproduct of fossil fuel consumption. And as long as political factors don't step in the way, we will see that implemented over the next 5 to 10 years. But, it's either going to be a zero-sum game of that we're basically all just competing for a ever-dwindling, finite resources, mm-hmm. or we realize, wait a second, no, just changing our thinking and start thinking expansive, start thinking large on the large scale. Yeah, we can do things that are no more impossible for us, let's say, than building 80 gigantic, incredible, beautiful, complex Gothic cathedrals in France after 1130 for the next 150 years. They did that. And I think there's something very important to be learned there, because something was able to galvanize that inspiration of the majority of the European, especially French population, to go, let's do this thing. And interestingly, when I look at a Gothic cathedral, the symbolism is all there. It's almost like it's prepping us intellectually, psychologically, emotionally, spiritually for this ascent. Because you walk into a Gothic cathedral and the whole geometry of it, the whole elevation of the vault is about creating a feeling of ascendancy. When you went into an old, say, a Romanesque, the type of cathedrals and churches that preceded the Gothic, you almost had this feeling it was dark, it was heavy, the structural elements were heavy, It was ponderous. You almost felt like you were bending down to be in this place. Windows were small, only small apertures of light coming in. The Gothic is suddenly completely different. Instead of everything being compressive, it's now all under tension. Just like the difference almost between the strings on a violin or a guitar have to be tuned and have to be under tension, or you get no music. Well, the structural elements of a Gothic cathedral are literally tuned. And with this new structural system and using the flying buttresses, and the flying buttresses, here's what a flying buttress does, because the forces are not being channeled directly just down ponderously, compressively to the earth. They're actually under tension. So that Gothic vault with stones mortared together with mortar that's as strong or stronger than the actual rock itself is acting as a unifying mass. And what happens is this. If I should have my metal rule, I can demonstrate it very
If your
nicely.
address is on that, don't show that.
Oh, okay. How about
blur
this?
It out?
Okay. So I should go get my metal rule, but it's under tension, so your buttress comes in from the side, and what happens if you remove the buttress is this. It wants to spring upwards. In fact, that's why it's even called, the French word translates as the spring point, where the vertical goes into the arch that's under tension.
Mm-hmm.
See, and it's that tension in those stones that acts to generate something within that the field of the vault itself. So the feeling when you walk into a Gothic cathedral, and even the shape of the vault is aerodynamic.
It's almost like it's pointing to space. It's like a spaceship.
It is. And I can show you juxtapositions, for example, of the vault of Chartres or other cathedral vaults juxtaposed upon, for example, the space shuttle or the fuel tanks, which are designed to minimize the drag, to minimize the shear power as it's passing through space. Well, it's the same geometry that you see encoded into the Gothic vault. Hey, just all you got to do is look at just your typical rural Christian church. And I do this all the time. You're driving along and you see the steeple with the cross. Remember, the cross symbolically symbolizes the earth. It symbolizes the material realm. It symbolizes the 4 ages of the world, right? Now, look at and I should pull it up and show you. I've got where I've juxtaposed a rocket nose cone on, and essentially it's got the same geometry as a steeple. And then at the top of that nose cone, you've got the cross, the symbol of the world, the symbol of the earth, right? And it's almost as if
lifted.
It's almost as if the steeple itself as a church is saying, look, here we're elevating the material world up to the heavens.
The ascension of humanity. It's like you said, the divine or the genetic mandate of human beings. And we have the technology to do this today. That's what's so amazing, because we have the ability to coordinate with human beings all around the world with very little resistance, if we are to have the right relationship with the technology that allows us to collaborate.
Yes.
We also have the understanding of physics that allows us to develop more and more sophisticated, more and more advanced, but also cohesive propulsion technologies with nature that allow us to go into space with less friction, with less energy.
Mm-hmm. Well, as an example, I'm compelled to once again share screen.
Yeah, it looks like a spaceship. It looks like a rocket.
Well,
yeah.
There we go.
That's got to be AI. I see you're using AI.
Of course it is. Of course.
Yeah. See, and we got AI as well. I like this discussion to kind of progress into the technology that we have today is extremely advanced. And there's definitely something to say about technology in the past also being sophisticated and advanced in ways that don't fit the common development of essentially computers and microchips and bits, things like that. But today we have let's say what we need to either get started on this immediately, meaning actually going into space, actually pursuing the development and the manufacturing and the engineering of structures in space that can help us continue to expand into the cosmos. And where we are lacking in that, we have the technology and the tools and the understanding to coordinate with human beings anywhere in the world, to share information, to communicate with each other, to also process mass amounts of data, to accelerate that process to develop anything that we need. Yet we have like you were saying, we have this scarcity mindset. We have this idea that we must fight over the grains that are left for us on the barn floor after all the hay has already been eaten. And the hay is still here, and we're just focused on making sure that we can control the area for when it is gone, so we can control the scraps, where we must shift into some type of idea that in the cosmos, things are abundant, resources are abundant, space is abundant.
For part of the first tactical dimension of this enterprise would be offloading our industrial civilization. You mentioned agriculture, which would be very valuable, but essentially our industrial civilization. Because if we can relieve the burden of mining from the Earth, because we can get virtually everything we need from the moon or the asteroids, then we unburden the Earth. And if our technology evolves, which it looks like it's going to be, where we're going to be able to create essentially massive alchemical factories in space, the Earth can be restored as sort of the garden paradise of the solar system. Mm-hmm. Plus, it also provides the models we would need when we start creating our own biospheres in space. The Earth is our teacher, our primary teacher. And that, I think, is what ultimately we're going to be doing, is we're going to be establishing biospheres, cosmic biospheres, not necessarily just on the surface of the moon and the Mars and so on, but in free space. And this is the interesting thing that Jeff Bezos, he's really behind the O'Neill concepts.
Yeah. Which space cylinders.
And interestingly, there's some new ideas that have come out through computer modeling showing ideal geometries for free-floating habitats, and it turns out that they're pretty much derivative of some of the geometric principles we've inherited from olden times. And I think that's ultimately where we're going to find a really mind-expanding expression of the concepts of sacred geometry when they're applied to cosmic architecture.
Mm-hmm. Yeah, and you mentioned an important point there earlier that I want to circle back to. You mentioned the offloading of the industrialization on Earth being offloaded into space, and you mentioned us specifically mining. I think that something that's not commonly recognized, because it's not commonly talked about, is the amount of materials that are on these near-Earth objects, the value of material. And just to give a few stats so people understand, okay, in 1986, asteroid DA, which was a metal-rich near-Earth object, about 85% metal composition is what was approximated. The value of the resources in iron, nickel, cobalt, and platinum group metals was $11.6 trillion US dollars. That's one. And that was a near-Earth object that was in range when we observed it to be able, at this time, to be able to go out and to mine. We have this technology. Another 3-kilometer asteroid, the 3554 Ammon, had $8 trillion in nickel and iron alone, $6 trillion in cobalt, and $6 trillion in platinum group metals, with a rough total of about $20 trillion in precious metals. And this is just 2 examples. We could go on and on, but it is so resource and mineral rich and metal rich that it would completely wipe this off the face of the earth as far as the need to mine here. If we can develop a system, if we can develop an industry.
Just one asteroid. Yeah.
It's amazing that we haven't talked about this more as a civilization. But you're right, Jeff Bezos is somebody who's kind of pushing this forward.
So this was from a great book I read back when it first came out called Rare Earth, Why Complex Life is Uncommon in the Universe, by Peter D. Ward, who is a paleontologist, and Donald Brownlee. I forget what he did, but they were both scientists. And they're talking about the astrobiological revolution. And this is the astrobiological is the idea that life on Earth was seeded from the stars. Okay? So another insight of the astrobiological revolution has been that attaining the stage of animal life is one thing, but maintaining that level is quite something else. New evidence from the geological record has shown that once it has evolved, complex life is subject to an unending succession of planetary disasters that create what are known as mass extinction events. These rare but devastating events can reset the evolutionary timetable and destroy complex life, while sparing simpler life forms. Such discoveries again suggest that the conditions hospitable to the evolution and existence of complex life are far more specific than those that allow life's formation. On some planets, then, life might arise and animals eventually evolve only to be quickly destroyed by a global catastrophe. Another factor clearly implicated in the emergence and maintenance of higher life on Earth is our relatively low asteroid or comet impact rate. The collision of asteroids and comets with a planet can cause mass extinctions, as we have noted. What controls the impact rate? The amount of material left over in a planetary system after formation of the planets influences it. The more comets and asteroids there are in planet-crossing orbits, the higher the impact rate and the greater the chance of mass extinction due to impact. Now, here's the thing. This is 25 years ago, based on research of probably the previous 10 to 20 years, right? What we've known in the last quarter century ups the ante considerably. There was no Younger Dryas impact known about in 2000. There was no Holocene impacts that are almost certain to have occurred, any one of which was perhaps capable of wiping out, let's say, a mid-Holocene civilization, such like the Bronze Age collapse, which seems to have been global and almost certainly caused by an impact or multiple impacts, and then a whole succession of secondary consequences as a result of that. And each of these times that we know within the Holocene that there have been incipient civilizations that have been on the rise, and then something aborts that ascendancy and then have to restart over again. Now, if we look at the last 10,000 years, number one, I think we could say that up until 5,000 or 6,000 years ago, the human population had not recovered enough from the Younger Dryas to actually form any kind of anything that looked like meaningfully a civilization, at least on the scale of the Sumerians or the Egyptians or later on the Greeks or the Romans or any of the the Mayan civilization, the Incan civilization, which I think the Indus Valley civilization, all of which I think certainly could qualify under the definition of civilization. Yet what we've seen is that there was always a break. There was a dark age that followed. There was a Greek dark age. There was the mid first millennia dark age that began in the mid 500s that took 300, 400 years for the planet, for civilization to recover from. So right now, what it appears is if we've had a window of opportunity in between planetary disasters that has allowed us to get farther ahead than any other civilization in the Holocene. Now, do we squander that lead by succumbing to the same kinds of forces and interruptions that have affected previous civilizations? See, you can get just so far, but then, you're building up your farm, you build your house, your barn, your granary, all of that, and then a tornado comes along and wipes everything out. Right. And then you got to start all over again, right? Well, on a larger scale, I think that's what we're looking at, record of civilization during the Holocene. And then, of course, it also leaves wide open what preceded the Younger Dryas. And I think there, if we're not bound by the straitjackets of dogmatic thinking, we have to be open to the idea that there may have been a whole lot more going on in prehistory than mainstream academia has been willing to admit. Because at this point, I think the evidence is overwhelming of something on a grander scale going on than we had imagined. But then clearly, we've got between us and whatever that potential hypothetical civilization is, we've got the Younger Dryas. And because up until within the last 10, 20, 30 years, it was not recognized the severity of the Younger Dryas and the role that it plays, preventing us from penetrating that veil and seeing what preexisted it, because the Younger Dryas was a global cataclysm, and it wiped out most everything, but not everything. But so here again, I mean, what this means is I think we're on a timetable, but we don't know when that timetable expires. So that should create every incentive for us to turn all of our resources to getting this job done, because once we've established the cosmic beachhead, number one, if there is an unavoidable catastrophe on a planetary level, our ability to reboot is going to be a hell of a lot easier, right? If we've already got civilization on the moon, if we've already got civilization in free orbit around the Earth, around into lunar orbit, wherever. If we don't have that, well, then we're looking at 5,000 or 10,000 year project probably of restoring civilization, assuming that it's not a planetary mass extinction event, which is almost certainly not going to be the case, because there's a big difference between, let's say, a KT type event that wipes out 3/4, or a Permian-Triassic event that wipes out 90% of all life on Earth, and the level of an event that could simply reset human civilization, right? There's a big disparity there. But this one down here is a whole lot more likely and common and possible than this one up here. I don't think we really need to be worrying about this. We don't need to be worrying, I don't think, about a 6-mile asteroid coming in suddenly in the next few centuries and hitting the Earth. However, a meteor storm with 100 Tunguskas, that's very real. That's very real. That's very possible. There's nothing implausible about that at all. And 100 Tunguskas would be about the equivalent of a major nuclear war. How long would it take to recover from it? Well, it all depends, I think, on the extent of the feedback effects. Because there could be extraordinary, extreme feedback effects, which we don't really know about. I mean, we can look at the Tunguska event of 1908, and we can see there were feedbacks, right? But what would 100 of them, or a couple of hundred of them, imply with respect to the global climate, with respect to changes in the biosphere, which we now know were a byproduct of the Tunguska event, the triggering of volcanism or seismicity, we just don't know. Or what if you had 10 objects that were, each one were, 10 or 20 times as massive as Tunguska. Tunguska was about 15 megatons. So 10 times that, well, 15, so like 4 times that, and you've got an explosion greater than the greatest nuclear weapons test, nuclear bomb test ever by the Soviet Union, which was 50 megatons, right? 4 Tunguskas would be the equivalent of 60 megatons. Now, if that was dispersed Oh, yeah, you better believe that's going to cause extreme damage. Let's say it doesn't terminate civilization, right? What does it do, though? Well, for one thing, pretty much it's going to knock out the global electrical grid. I mean, the question becomes, even though it maybe wouldn't cause a mass extinction, of course it's going to cause a mass mortality event of people, of population. And the question is how much infrastructure would be destroyed. If it's a single impact, yeah, in that region, let's say a major impact of something that's 10 times the volume of Tunguska. Well, now you're taking out a state somewhere between the size of Pennsylvania and Texas, right? But you're not, most of the rest of the world would survive. But they would be plunged into an economic nightmare for, probably a decade to recover from something like that. We don't want that, right? And we're not prepared for, we're really not prepared yet for any of that.
Yep.
You see, we're not. But we need to be.
Because that decade without preparation could be a lot longer than that. Or that decade could be shortened if this does happen to a year, to months if we are prepared. We're not even thinking about it. We're not preparing.
Now, we're going to do a deep dive at some point into the cosmic environment in which we find ourselves and look at what is the variety of potential catastrophes that could be visited upon the Earth. Well, we just talked about some of them, but we haven't talked about like what would happen to a major impact into the ocean, right? And this is what I'm hoping to talk to Dr. Dallas Abbott about in the next couple of weeks, because she has done a lot. She's probably one of the leading experts on what happens with impacts into the global oceans. And she's done some incredible work now on documenting the existence of tsunami deposits that are much too large to have been the result of earthquakes or undersea landslides, which typically 30 to 40 meters is pretty much about the maximum, looking at a catalog of all of the tsunamis that are related to earthquakes.
Tectonic movement primarily.
Tectonic movement, right?
Yeah.
But there is paleo evidence, I will say evidence of paleo tsunamis that are much bigger than that, that are 300, 400, even over 600 feet in height when they make landfall. So that's not from an earthquake, right?
Yeah, we looked at the one off the coast of Madagascar.
Yeah.
Chevrons, the evidence of that. And I mean, what do we do? What do we do to prepare for things like that when we can't talk about the evidence, when we are trying to keep our heads in the sand to not, or at least mainstream academia is. Obviously, you're not, and we're trying to spread awareness of these things, these events to the world, while also talking about it in a way that creates hope. We do have hope for this. That's one thing that I think you and I both want to portray through this podcast, that the reason why we're doing this is not to point at these things and say we're screwed. This is what's coming for us. We want to be aware. We want it to be real, so people realize that we have to do something. We want to catalyze movement and action.
Yeah. So there was a comment in one of the comments that on one of the videos recently.
I love these.
Well, which sounded familiar, which I've heard a lot. This is, you're just preaching doom. You're a doomsayer. In fact, on this comment, he called me a doomsayer. And,
generally annoyed doomsayer.
Yeah. That's not what it is. That's not what it is. I mean, that's just indicative of stupidity, in my opinion, because it's like, look, if you're gonna go live on the coastline, you have a beautiful beach house, and you build right on the beach in Florida, and you don't even think. Well, so when somebody say, well, you're planning your house and your development there in such a way that you might survive a hurricane, right? So what do I need to survive? Well, what is the maximum wind power? What is what are the effects of all of this? How often does it occur? This is all the stuff you got to factor in.
Don't be so negative, Randall.
Well, yeah, or you can go, I don't even want to, you're a doomsayer. I don't want to know about winds
Exactly.
150 miles an hour. I don't want to know when the last time a hurricane made landfall here where I'm going to build my beachfront house. I don't want to know any of that, right?
Yeah.
It just, that's what, all I can say is that's a mindset of basically, if you had a whole society of people with that mindset, that society would become extinct.
Oh, yeah.
It would become extinct.
Probably for the better.
Maybe so. But, first thing, I think of the analogy of what I've done for a living. I build buildings and repair buildings, restore buildings that are obsolete to functional life, etc. Let's say somebody calls me and they're looking at buying an old building in a decrepit part of town, whatever, or out in the country, doesn't matter. They're looking at buying some property and there's a building on it, and they want to know, what do we do? What is going to be the economic cost of restoring this building to a functional life? Essentially bringing it back to life. It's sitting there, maybe abandoned. When we did the Wheelhouse Pub, it had been sitting there nearly a decade. So what was the first thing you do? You go in and evaluate what's there. And what are you basically looking for? What are the problems? If somebody calls me and they said, look, the corner of my house is sinking. Look, I've got right next to the corner of this building, there's big cracks forming, right? So we need to have that fixed. Well, how do I go about fixing that if I don't know what caused the problem? So I look at it and I study it and I go, okay, let's see. You've got this guttering system up there to convey water flow off the roof when it rains. You've got a downspout, but look down here at the end of the downspout, it's rusted out. And for years and years, that rainwater has been going down directly into the ground under the corner of this building, has caused the saturation of this ground and get soft. And so the weight of this building has compressed it. So two things we got to do. Number one, we got to excavate, and we got to put a nice big footing down there, let that set up, and we can jack up the corner of the building. Then we can backfill with something. We'll have a pier under there. We'll backfill. And then we don't want the problem to recur, so we reconstitute the drainage system and we convey that water well away from the corner of the building. Right? So we come up with solutions. Mm-hmm. But you don't come up with any solutions until you've defined what is the problem you're trying to fix. You see?
I see. You got to take care of the foundations, and the only way to the only way to mitigate future risk is to identify what that future risk is.
There we go.
Yeah, you can't just be afraid. So, all right, take inventory for us, Randall. You're doing an evaluation of planet Earth and our ability to protect ourselves. Give us the positive and the negative.
The negative, I think, is just going to be in people's attitude. If people, the negative, I think, is too many people thinking, oh, we can't do this. Why should we be going out to space when we've got so many problems on Earth? Which I've heard over and over and over again. That to me it's mental, emotional, psychological. That's the biggest negative here. I think whenever people come together with the belief that amazing things can be accomplished, And I'm a firm believer in always, go ahead, reach a little farther than your grasp, right?
What is your relationship with reality? Do you think it is stagnant, or do you think you can create change and we can create change?
No, I think we can create change, but you got to go beyond a little. You got to aim high, I think. Here's an analogy. Like, I had a couple of years of martial arts, years and years and years ago, but I do remember one of the things, and I've forgotten most of what I learned, but a few of the things I learned. Here's one of the things I learned when the teacher taught me, if it comes to it, you want to avoid it whenever possible, but if it comes to it and you got to knock somebody out, what you're doing is you want to put your fist on the backside of their head, not the front side. In other words, you're not, and it's the same way kind of when I'm drumming. Only it's the opposite. See, when you're drumming, percussion now, not trap sets. When you're drumming, you're actually playing as if the head of the skin of the drum was like a quarter or 3/8 of an inch above the actual skin. Because what you're doing is you're coming down and you're bringing your fingertips back up in a sense so that you're actually kind of catching on the rebound. Does that make sense?
Yeah.
Like it's like you're pulling off like this. You're not playing the drum itself. You're kind of almost catching the drum head on the rebound. Does that make sense?
It does, yeah.
And then, because otherwise, the longer your fingertips linger on the skin of the drum, the more damped, the less resonance there's going to be. You're hitting
Like
somebody, and if you're knocking somebody, you're not just aiming for the front of their face. You're actually trying to put your fist through
right
to the backside.
Through their face. Yeah.
Right through their face, right? What am I trying to say here? Well,
we got to shoot farther. We don't need to just look at what is only possible in our minds today. We got to think bigger than that.
Yes, that's right. That's right. I mean, I'm already fantasizing about recon expeditions to Europa, things like that. You know, I'm fantasizing about, well, that the entire solar system essentially has been laid out for life. I mean, we can't talk about this too much tonight, but at some point we're going to talk about that when we get into the architecture of the solar system we inhabit. You cannot change the parameters of this solar system by much and not have this whole thing of advanced complex life on Earth instantly going away. Evaporating, yes. That's right.
Yeah. I mean, it's amazing. It's a miracle. Okay, so on that, the negative is there's the naysayers, there's the cynics that say their relationship to reality is that things are stagnant, things aren't possible. That's our negative inventory. What's our positive inventory when you're taking a look at what we have, deciding what we're going to build? What do we have to work with?
Well, right now, I mean, with AI and robotics now in our toolkit, it considerably enhances our capabilities and our reach. Because now we should be, you know, I'm definitely in favor of the human presence in space, but it should be preceded by as much in-depth robotic recon as possible. The more we learn about these environments before we go to them, the better it's going to be. So yeah, with the mental attitude, the aspirational attitude, but you know what might serve to galvanize that is, number one, we put the alternative out there. Here's what we can do. Here's what we need to do. Why? Well, we can do it because, you know, look, we're 7 billion, 8 billion people, and we're on this planet, but the planet really could be considered a seeding ground for the solar system. And we're here on this planet, and we can create a much larger world and all of the things we've just talked about, and put that message out there relentlessly. And you'll have people who, I think a percentage, maybe 5% to 15% of the people are going to hear it and they're going to, yeah, that makes total sense. They're going to instinctively, even if they don't intellectually grasp it, they're going to instinctively know that sounds right. And then that will motivate them to try to learn more about the specifics and hopefully inspire young people to come up and get involved in science and technology and engineering and math and astronomy and catastrophism and all of these things that are relevant to this enterprise, right? So that's kind of like, in my mind, like sort of preparing the field. Mm-hmm. Then what could galvanize a large portion of the human population would be the next time a Tunguska event occurs. Except now we've got the technology we don't have to wait 20 years to go study it. It'll happen real time. And then we'll know that, yeah, okay, here we are. We are cosmically vulnerable. And I think that could change a lot of minds overnight if another Tunguska happened again. I don't want that. I absolutely don't want that. But catastrophes happen. And if we're not prepared for them, let me look what just happened in Texas. They weren't prepared for it. They weren't prepared. Now, it's being blamed on Trump. I don't know whose responsibility ultimately that should be. Absolutely, there should be coordination on a national level, but that was a regional event. Texas is a big state. There's no reason why Texas should not have had the wherewithal, the technological wherewithal to track an incoming rainstorm and communicate to people. You got to get to high ground. Yes, I mean, is there a role for the federal government in helping to coordinate the efforts of states? I think so, but should the states be dependent upon federal? No, because the states have fully the capability of monitoring their own environmental conditions and knowing if something like this is going to happen, probably more than the federal government, right? And you don't have to go through the loop if the warning has to come from Washington or the federal government before it gets to the people. I think that's going to be a little bit more complicated than if it's coming directly from the Texas state government.
Yeah.
And, it's like, do we need the federal government? Probably, but maybe not. It depends. Like if you look at Texas now, let me use the example of Tennessee. This is a small scale example, but some of my friends that are Masons in Tennessee are involved in a program where voluntarily the Masonic lodges around the state are coordinating their efforts. So if there's a disaster, and the two big disasters that Tennessee tends to be affected by are floods and primarily floods, but also tornadoes. Mm-hmm. Those seem to be the two that cause economic disaster and worse in Tennessee. Well, what they're doing is they're organizing that if like a county is hit by tornadoes, a town is destroyed, now people have to come together. They're going to organize like a private sector where the lodges will come together and help each other out. So if in Western Tennessee a tornado comes through, then the other lodges around Tennessee will come to their aid and help them rebuild. Okay, if there's a flood in Eastern Tennessee, the lodges will come in the same thing. Now, I think that's a very good approach, that you've got this grassroots, on-the-ground level first responder system in place. What have we seen with FEMA, going back to Katrina, going up to the floods in western North Carolina last October?
Yeah.
Initially, they're an obstruction to rapid deployment and rescue of people. And now we're seeing already the same thing in Texas.
Yeah, I think we could agree that the institutions need to be reformed. There needs to be some type of reparation. But the example that you're giving, if we can extrapolate that outward, if we can have a global effort for something like that, that's a sign of prepared. So let's say that there is an impact event. Uh-huh. It's not just like you're saying, it's not just a lodge level thing. It can be people from all around the world who are prepared if a disaster like this does happen to help affected regions, to help affected peoples.
Was that you and I that talked about we did, I believe, the Teton Dam disaster?
Yeah, we did.
And how people spontaneously came from far and wide to help in the relief and rescue efforts? That is a beautiful example. And what that is to me, that represents the American spirit, which one of the phrases to describe the American spirit, I think, is self-reliance. And when you have as much as possible on the self-reliance not just on the individual level, but the community level, the state level, you don't have to rely on giant, outsized, remote bureaucracies.
The spirit of freedom.
The spirit of freedom, yes.
That is what it is, because self-reliance is taking ownership of your own freedom. And we want that spirit to extend beyond borders to just people in general. I hope that we continuously speak about these things, and maybe our politicians will over time. But it's the idea that through taking ownership of yourself, your community, what happens to you, the things around you, then you can experience freedom, and that extends outward. And then you find more people like that, and it becomes a community of people, regardless of the geography of it, that can solve problems quickly, that can coordinate, come up with solutions.
And this, what's happening in Tennessee is just, it can serve as a model for, like you just said, a much larger network. And I'm of the mind that, begin to create these networks and bypass dependency upon the centralized bureaucracy. And then either the bureaucracy will evolve and become more effective, or it'll become extinct. One of those two.
One of the two. You got to put pressure to create diamonds, right?
Right. I mean, if it gets to the point, right, we don't need you guys anymore. We'll handle this. We don't need it. We don't need you anymore. But, I've done a little research and written about this, what, in terms of how much money is extracted from each state each year that goes into the coffers of the centralized giant bureaucratic government in Washington. And it's extreme. And this is another thing, maybe an idea to promote, to try to get people to start thinking outside the box, is imagine if those $1 trillion a year that's being extracted from the excess of $1 trillion a year that's being extracted from the private sector and the state level and the community level could stay in the private sector, in the state level, in the community level. What could those resources do? And I think at this point, if we ever needed the federal government, maybe so, going back early 20th century, whatever. But personally, I don't think we ever really did. I think that we had a system whereby state governments were going to be more than capable of handling the 98% of the needs of their state citizens, and to whatever extent something outside of that was necessary, voluntary associations amongst various states would organically form. Just like, okay, hurricanes, Atlantic hurricanes are going to affect Florida, Georgia, North and South Carolina, maybe Louisiana, Mississippi. So why not the Southeast states form an organization that we're going to help each other be able to respond to hurricanes, to mitigate the disasters of hurricanes, to help in recovery efforts? We're going to form this organization, the Southeastern American states of hurricane relief, whatever you call it. Pacific Northwest, what do you got up there? Well, you got volcanic stuff up there, and you've got some earthquakes, right? Washington, Oregon, there again. But the Oregon and Washington are not being affected by Atlantic hurricanes. So do they need to have infrastructure in place to respond to Atlantic hurricanes? Well, probably not, right? The Tornado Alley, those Midwestern prairie states, well, they're not affected by hurricanes except in very rare circumstances, but they get dozens and up to hundreds of tornadoes every year. So it would make sense for the states from, Kansas to Nebraska up to Minnesota and the Illinois, the states that are now in the tornado belt, they would organize to affect tornado relief or tornado mitigation, whatever it might be. That's the point. If you're in the forests, if you're along the coastline, you probably don't need to have, forest fire suppression in place. You don't need to spend your money on that, right? But if you're in the forested areas of western Montana or Oregon, then you should have that in place and respond to it. And I think that could, on that level, I think it could be more effective than relying on a centralized authoritarian bureaucracy like FEMA.
It has to be people. And you're speaking of all these disasters that are affecting different environments, but we're all on Earth. And one of the disasters that will affect all of us is comet impacts, some type
Comet
of
im-
impact event.
or potentially a
Solar flare, yeah, some type of solar event.
We could have a solar event that could knock out our electrical grid. That would take. Can you imagine the chaos that would ensue if an electrical grid got knocked down?
It would
Now,
be
50
chaos.
years ago, it wouldn't have mattered too much.
Yeah.
But now we're all dependent on it, and we're not ready for that either. But
we can be. We can be ready for it.
Yes, we can be.
And there's lots of good ideas about this. This is one of the things that people do talk about as well. There's plenty of smart people who have dedicated their lives researching this and developing technology to mitigate this. It's just when you don't have the amount of funding or the amount of resources flowing back to that, because it's like the idea of you only take care of your body once you get sick, right? It's like, oh, when you're healthy all the time, you're like, oh, I don't need to take care of myself. I'm good. And then you get super sick. And after you get super sick, you're like, oh, well, I'm going to exercise more. I'm going to eat healthier. I'm going to take my supplements. I'm going to get more sun, so on and so forth. Well, because we're not getting a big punch in the face from extraterrestrial fist, I guess you could say, we're not thinking about taking care of ourselves. We're not thinking about how we can avoid being sick with the same level that we are saying, same level of investment in energy that we're saying we need to extract, we need to build the next phone, we need to so on and so forth, whatever thing we're focused on.
Well, there's a lot more to talk about in this, and I think that we're going to devote, ongoing discussions to this, because part of this it's unfolding as we speak on a day-by-day basis.
It is.
And I'm 100% about accelerating the process, getting resources back towards positive ends rather than, there was one other way that we could cause the extermination of our civilization, and that's if we do it to ourselves through nuclear war.
Yeah.
And we're flirting way too dangerously close. And that needs to stop. That needs to stop immediately. Right? We need to start having, instead of Netanyahu being in Washington, it should have been Putin in Washington and Xi Jinping in Washington and a couple of the mullahs from Iran in Washington, and saying, hey, here's the deal. Here's the options in front of us. Look, during the height of the Cold War, Khrushchev comes and visits Eisenhower in the White House. He comes and he visits Kennedy in the White House. Brezhnev came, Kosygin came. Has Putin been here to the U.S.? I think he has, but when was the last time he was here?
I don't know. It's been a long time now.
Yeah, it's been a long time. And of course, if he comes here, and just like when Khrushchev came, he was demonized and portrayed as this one-dimensional figure, but when he came here and he was interacting with journalists and out touring Disneyland and all of this kind of stuff and having a good old time, he became humanized, right? And right now we're seeing the same thing, demonizing Putin. And not to say, oh, you can't say anything positive about the Russians or Putin, or you're now labeled a Putin stooge, right? Well, I mean, good Lord, they can be saying this very same thing about us. You're a Trump stooge.
Say it about
it's designed to shut down dialogue, so that all we have access to is the prepackaged, censored narrative that they're going to feed to us, right? But we've got to go work. We got to go beyond that.
Yeah,
we can't let ourselves be controlled by that, and we can't constantly keep giving in and making excuses for it. And I am right now, I'm as critical of what I'm thinking of as the Trump betrayal as anybody. I mean, there was a guy who said, I'm going to stop the Ukraine war with Russia on day one. What happened to that? right? What happened to that? Well, I was cautiously optimistic. I didn't vote for him, but I was cautiously optimistic because I knew that Kamala Harris was just going to be another tool of the deep state war machine. There was no doubt. But there was a whole faction of Americans that was seeing how we're getting screwed, right? And I think the question in my mind now, was Trump sincere, or was he just citing what he knew was going to galvanize the base and get him elected? I don't know the answer to that.
Yeah.
Either one, to me is a betrayal.
Yeah.
If he was sincere, but now he's in office, in power, and what? Is he being blackmailed? I don't know, but the argument could be made with this whole development.
It could be.
Yeah,
who knows? I mean, maybe we'll have a longer discussion about the political environment of the world, where we dive into more specific situations and we unpack this, because it's interesting.
Well, yeah, for now, what we started this conversation with, talking about the three Russians and 3 American scientists working together on the International Space Station. We need millions of people talking about that.
Yes.
We need American people talking to Russian people and saying, let's do this thing,
yes.
right? We, the people of America, are not your enemy, and you are not our enemy, right? It's time for us to bypass these governments that are dedicated to this ongoing conflict. And, it kind of started happening during the Vietnam War, and we can go back into our lessons there. But, hey, nothing talks louder than getting 50,000 people locked arms and completely surrounding the Pentagon, which they don't want you to know about, that happened in 1971. Mm-hmm. They don't want you to know about that. And there were bad things going on for sure then. I mean, it was certainly fascistic to take 50,000 people, herd them into a baseball stadium, and wrap the stadium in barbed wire, which they did, if you were out there protesting the war. But ultimately, that served notice to the government that, no, you're not going to keep doing this. You're not going to keep stalling. They drug it out, of course, as long as they could.
Yeah.
But in the end,
Yeah, I think you said it well. You said it well. We need everybody standing up, understanding that we're the change.
Uh-huh.
It starts with conversations. It starts with coordination. And it's not, it's a conscious effort. It's not, everybody's got stuff going on in their lives. We all do. We've all got things that we'll constantly have to take care of. But the global culture does have to shift. It can't just be about how do I get by, or how do I get by in this game, get the best score with the best house or the most money or the most comfort or whatever it is. The global culture has to shift, and there's room for all of the things that we said. It doesn't mean we throw everything out that we know and that's familiar, that provides us comfort. It means that we get the opportunity to do something great, to build our own Gothic cathedrals and do it globally. Well,
yeah.
Randall, I wrote another story. Do you want to hear it to close us out?
Oh, I do. Is that sort of the concluding story?
Yeah.
Okay. I could go on a little more, but I think it would be good to, take a break here and then pick up this conversation on our next episode of The Big Picture.
Let's do it. Well, we started off this conversation talking about the International Space Station, and I think it's important to make it somewhat real. So let's imagine for a moment that 100 years from now, there's a child that's standing on the surface of another world. Maybe it's Mars, maybe it's the moon, maybe it's a free-floating space station orbiting in our solar system, and she's looking to her parents and asking, how did we get here? And it's possible that they'll tell her about the technological breakthroughs, the propulsion engines, the fusion reactors, the oxygen farms, the AI that helped make it all possible. But maybe, just maybe, they'll tell her about the 11 people that were on the space station, or the conversations that started to happen. They'll tell her about how people from the United States, from Russia, from Poland, from Hungary, from India, and hopefully from China, from other countries that were sometimes in conflict, floated together and came together to solve problems. How they shared experiences, they shared air, they shared meals, they shared laughter, and they ran experiments together to grow food, to heal disease, to understand life itself. And they'll say it wasn't just the technology that made it possible, it was the choice to work together. It was our relationship to the technology. It was our choice to build bridges and not walls, and it was our choice to look outside of Earth for resources and not just at the ground. Because hopefully in that moment, early decades of the 21st century, we proved that cooperation isn't just a fake dream, a pipe dream. We proved that we have a blueprint for this, that the International Space Station, or at a smaller scale, the coordination of building Grand Coulee Dam, isn't just a one-off thing. It's a mirror of what we can do when we're at our best. If we can collaborate in space against the odds, above politics, above the gravity of the Earth, then why can't we do it here? Why can't we do it now? And this reminds us that the International Space Station isn't a utopia. It's simply a decision. It's a practice. It's a horizon that we can walk towards together. So hopefully when we all look up, when we see stars, when we see the clouds, we see city lights, we can remember that humanity is already out there. We're already working together, and that our story is just beginning, and that the rest of it, well, that is up to us. That is up to our coordination and our commitment to humanity.
Nice. Well, let's remember the state motto of Kansas. To the stars, despite adversity. You ever heard that before?
To the stars, despite adversity. I love it.
State motto of Kansas. I have no idea where they came up with that.
You ever been to Kansas and looked up?
Oh, yeah. I've been to Kansas.
Yeah, when you're out there in a ranch, in the ranch land, western Kansas, man, you look up.
Yep.
You're seeing the stars.
You are seeing the stars. Absolutely.
All right, brother. Good night.
All right. Next time.
Next time.